You may have read all the hoopla about the upcoming total lunar eclipse, which occurs on the night of, that separates April 14th from April 15th. The total lunar eclipse occurs in the very early morning of income tax day. Anyway, I thought we'd like to play with stellarium a little bit more and actually see what that eclipse looks like from the Earth, and also what it might look like from the Moon. So let's get started with the first project first. Let's get stellarium up. There's stellarium. You notice that I'm located at Iowa City, America's only real city, located in America's only real state. But I would like you, when you replicate what I'm doing here, to actually set your location to the Shawnee, Oklahoma. And you can set a location by looking at the Jigui, and up at the very top it says location window. You can also get there by using the F6 key, function 6. You notice that I have mine set for Iowa City. You want to set yours for Shawnee, or need be Oklahoma City. Having done that, the next thing I want to do is set the clock. Well, according to the Peterson Guide to the Stars and Planets on page 361, that eclipse will take place. The moon will enter the umbra, the darkest part of the shadow, at 6 hours, 0 minutes, Greenwich Mean Time, or Universal Time. To convert that into local time here, we subtract 5, and then ideally another 1/2, because we are located almost in the next time zone. But I will just subtract the 5, and we'll get within a half hour of the correct time then. And totality will begin at about 7:07 Universal Time, which is at about 2:07 our time. So around 1, the moon will enter the deepest part of the shadow, and at about 2:07 it will leave that. Totality will end at 8:26 Universal Time, which is 3:26 our time, and the moon will leave the umbra at 9:34 Universal Time, which is 4:34 our time. So let's see if we cannot see what that might look like. I'm going to first of all set the clock. To set the clock, I need to look at F. Whoops, I'll use the GUI, I've forgotten. Time set is F5. Okay. The date time window. I'll go, it's 2014, April 4th month. I'll go to the 14th day. Go back easy. Well, go back this way. And the time I will set, let's see, moon enters, I've forgotten what Pasikoff says. He says the moon enters the umbra at 1 o'clock our time, 1 a.m. that day. So I'm going to set this at 0 hours. And then 1 hour and 0 minutes. Okay, and I don't really care about the seconds. So there's the time. I'll go with this a little bit before that. Let's make this 0 and make this about 55 minutes. some time to play around with it. Okay. I've got stars and so on showing here, so I will turn them off by hitting the S key. And planets labels I can turn off by hitting the P key. Okay, and there is, presumably, I left click it, it will be the moon. I will center the moon by pressing the space bar, and then I will click the virgule, which is the forward slash. I'll hit that once, and I'll try it once more to see if I can make the moon any bigger. No, I can't. It's as large as I can make the moon. And then I will simply wait. Now what I could do is advance the time a little more quickly. So let me do that this way, the double arrow to the right. Click it once. And I'll make time go by a little faster. About 10 times as fast, actually. It's about 3 minutes before totality. Pardon me, before the moon enters the shadow, the umbra, the darker part of the shadow. I'm waiting. I see the shadow beginning to creep in on the left side of the moon. At least I think I do. Nothing to do now but wait and let time go by. Well, I can cheat a little bit and add an hour onto that with very little trouble. I'll do control and equals at the same time. Now we can really see the shadow. Yes, it's quite a bit after 1 o'clock. And now I'll wait. I could sing a song for you, but I won't. It requires an admission ticket, which you can't afford. Notice the shadow is sort of a ruddy color. That's because the light now coming around the Earth is refracted by the atmosphere. In refraction, red light is scattered the least, so the other colors are scattered out, and what is left getting through around the Earth's atmosphere is the reddish light. Covering more and more of the moon. You could watch this for another hour or so. So let's add an hour to the time. Let's control equals. Now we're after totality. The entire moon is now in the deepest shadow, but we're getting some reflection of the red refracted light from the Earth's atmosphere on the moon. And it's now almost 2:30 our time. Shouldn't be too long, and we will leave the maximum totality of this eclipse. When is that supposed to end, if you ask? Let me double check. Totality ends at 3:26 in about an hour. Let's add an hour. Yes. You see that the shadow is going away. Let's add another hour. .433, however, moon still is apparently in the penumbra. Let's add another hour. Ah, now we're out of the penumbra either, and the moon is back to its normal self, outside of the Earth's shadow. So we watched the total lunar eclipse on April 15th.